Today's podcast is all about experiment design. In honors chemistry, we're going to be designing a lot of our own experiments, and so we need to make sure that you're familiar with all the different parts. I'm sure you've gone through these before in science classes, but it's really important that you really understand each part in order to be really successful with your own experiment designs. So we're going to go through the different parts. Don't write this whole list down now. We'll go through each one individually. And what we're going to do is pretend that we're doing an experiment where the research question is, what is the effect of running on heart rate? And we'll go through all these different steps here to describe that. First of all, you always start with an independent variable. What do you want to figure out the effect of? And how will it affect the dependent variable? So the independent variable is the thing that the researcher sets. I always say the IV is the thing I change. In this experiment with heart rate, the independent variable would be the amount of running. The researcher might decide to set different lengths of running, like 100 meters, 200 meters, 300 meters might be your different groups of people running. You also need a dependent variable, the one that you measure, to figure out what the effect of the independent variable is. I always say my DV is the data. It's the stuff that you put in the body of your data table. In our experiment, that would be heart rate measurement. We also need controlled variables. These are often called constants, but we use the vocabulary controlled variables a lot because if you're in IB uses that word, that vocabulary a lot, and so we will use that as well. It's basically anything in an experiment that has to be the same throughout, that can't change because it might affect the dependent variable. And we only want to see the effect of the independent variable, so we don't want anything else to change. In our experiment, there's lots of possibilities for controlled variables. What time of the day we do the experiment, what are the weather conditions like, what are the age and genders of the subjects, how fit are they, and I'm sure you can think of a lot more. They're just anything that has to stay the same throughout the experiment. Now, a control group often gets mixed up with controlled variables, but they are not the same. Some experiments don't even need control groups. A control group is a group of trials or a group of subjects in an experiment that have the independent variable set equal to 0. In the experiment we're talking about now, we would have a group of people that didn't run, so that we would know resting heart rate and how just sitting affects heart rate, if at all. Now, often there are experiments where a control group isn't necessary. For example, if your independent variable is color, let's say, how does color affect something? You can't really have an independent variable with no color. Everything has a color. So that doesn't really make sense to have a control group in that case. Although some people might argue that white or black might be a control group. Depends on the experiment. Baseline measurement. Sometimes there's something that you have to know before you do the experiment so you can really tell how the dependent variable has changed. And so a baseline measurement is just something you have to measure before you start the experiment. In the experiment with heart rate, we need to know what the person's heart rate is before they run, their resting heart rate. We also need repeat trials in an experiment. Repeat trials are anything where a group of things is done over so you know if your data is repeatable. Now, the question always comes up, how many repeat trials should I do? Well, the real answer to that question is to look at your data. Your data tells you how many repeat trials you need to do. You should always start with about 3, and if the numbers are all over the map, you need to do more. If they're all very similar, then you've done enough repeat trials. So it's always good to look at your data. However, time and money also dictate how many repeat trials you can do. In our class, most experiments we do will do 3 repeat trials. In this experiment with heart rate, repeat trials would be when you have several subjects in each experimental group. In other words, you have maybe 10 people that run 100 meters, 10 people that run 200 meters, and 10 people that run 300 meters. And each of those people within a group would be repeat trials of that same distance. So those are the main things that you need to consider when you're designing your own experiment. Make sure you're familiar with those, that you can identify those in different kinds of experiments. And then we'll be all set to jump in and design our own.